now we will start integration testing. First of all, as we have seen in the component testing level, that at every test level we will first of all discuss the objectives. So what are the objectives of integration testing? Normally integration testing is performed to expose the faults in the interfaces, or you can say between the components and system. How we perform the integration testing? I will give you one example. For example, you have two different components, and then this component is passing a value to this component and then getting some value back. So in that case, you will check these interfaces, that either these interfaces are working properly and both these components are interacting or interfacing with each other properly. So these components were already tested during component testing, and during integration testing we are checking the interfaces. So it focuses on interactions between components or systems. This we will see here in the component integration testing and system integration testing. So the typical objectives of integration testing are reducing risk. Yeah, for sure. If you found some bugs or some problem in the interfaces during integration testing, then this will not carry to the system level or system testing. So it will reduce the risk. Verifying whether functional and non-functional behavior of the interfaces are designed and specified. During integration testing, we also see all the functional and non-functional behavior of the interfaces are performing well or not. This functional and non-functional behavior we will see in more detail in this chapter and upcoming chapter as well. Just for the time being, just remember, functional is the functionality, like for that particular component, what this component should do is the functional behavior, which is the requirement of the customer. And non-functional is the something which you cannot give the answer in yes or no. Like for example, is this system is responsive? Is this system is complex? Maybe for some user it's complex, but for some user it's not complex. Let's say you are developing a module for a shopping cart system, and then you say its functionality should be like this: if I check out, then there should be something in my cart. It's a functional requirement. So it is known as a functional requirement. But for example, user say that the card should look like this, or whenever as I click on the card, immediately it should show how many objects are there in the cart. So like it's a kind of how much responsive the system, and user say that the GUI or the user interface should be more bold, should be in like more in size, or the text size should be more. It's a kind of non-functional requirements, but we will see these topics in detail in future. Then during integration testing, building confidence in the quality of the interfaces. You say that my interfaces between different components or systems is working properly. Finding defects which may be in the interface themselves or within the component or system. And then during integration testing, maybe you can also find the defects not only in the interfaces, but also you will say that this component is not responsive, or is not responding in the same way as I am expecting. Maybe this component is not implemented in the right way. So during integration testing, you can find many defects not only in the interfaces but in the components itself, preventing defects from escaping to the higher test level. This is the objective of component testing as well, integration testing. Like if you find an error or a defect here, then if you remove that error or defect in the integration testing, it will not escape to the higher test level, to the system testing, let's say. So as with component testing, in some cases automated integration regression tests provide confidence. Like as we do the automated testing in some cases for integration, same is with the for the component, same is with the integration testing, that it provide confidence that changes have not broken existing interfaces, component or system. That for example, if you are developing your system and you have automated your test cases for the integration testing, that as system is growing, it will automatically run some test cases to see if interfaces are working properly or not. There are two different levels of integration testing described in this syllabus, which may be carried out on test objects of varying size as follows. Like there are in integration testing itself, there are two kind of integration testing. One is component integration testing. As the name suggests, we have two different components, like component 1, component 2, and we are checking interfaces between them. Then it will be a component integration. It focuses on the interaction and interfaces between integrated components. Component integration testing is performed after component testing and is generally automated. So component integration testing is only performed when these components are individually tested during component testing, and now in component integration testing we are integrating those components and then we are testing the interfaces or interaction between them. In iterative and incremental development, component integration tests are usually part of the continuous integration process. This we will see: continuous integration, continuous development. It is not the main topic of this ISTQB foundation level, but anyhow we will see many times this term in upcoming chapters. So normally the component integration tests are the part of CI. Then the second type of integration testing is system integration testing. For example, we have those who are familiar with the, let's say, embedded system. We have a software which is a one system of software, and we have a other system which is hardware system, and then we are doing integration testing between them. We are doing interfaces. We are looking at the interfaces and interaction between software and hardware components. So it's an example of system. These two are different systems and they were tested independently in you can say system testing, and now we are doing system integration testing. We are integrating both independent systems. In component integration testing we had different components, but in system integration testing we have different systems that we check. It focuses on interaction and interfaces between systems, packages and microservices. Like for example, you have your own shopping website, but for the card system or for the payment method you have purchased a different microservice from a different company. Like maybe you are not expert of the payment method, so you have purchased a ready-made software, or sometimes we call it as API, application program interface, from a different company. So it's a different system, this payment system, and then you have your own shopping system. You merge them, two different systems, and then you test them. So it's a system integration testing. System integration testing can also cover interactions with and interfaces provided by external organization, as I've told you, web services. In this case, the developing organization does not control the external interfaces, which can create various challenges for the testing. Ensuring a test blocking defects in the external organization's code are resolved, arranging for test environment, etc. Like for example, you have purchased a system from a different company. You don't know what is inside the code. They have only provided you can say a wrapper function or an application program interface API. So in that case you need to be very sure that your system is completely integrated with the external system. So this thing is very critical. System integration testing may be done after system testing or in parallel with the ongoing system test activities in both sequential development and iterative and incremental development. Like as I told you, maybe you have a software system, you have a hardware system. You have tested them individually. We haven't discussed till now the system testing, but they are different system, and you have done the system testing already, and now you are doing the system integration testing between hardware and software. So this system integration testing can be done in parallel with the system testing, or with already tested systems you can do the system integration testing at the end. Now what are the test bases? As I told you, in every test level we will discuss first of all what are the objectives, and then we will discuss what are the test bases, like what products are, what documents or which things you have based on which you test you perform your integration testing. So this we will see here, what are the test bases. So for integration testing, you will have a work product that can be used for integration testing include software and system design. Like you can say here, as we have discussed in V module already, higher level design. For component testing, the lower level design. You need the code actually. You need the component specifications. But over here, you have a higher level design. So you only need to know how the software is designed and how they are communicating with each other. Maybe those who are familiar with the unified modeling languages, UML, they know the sequence diagram as well, how this whole sequence is performed between different different components or system. So sequence diagram. Then interface and communication protocol specifications. Like if one system or one component is communicating with the other component, you need to know about the specifications, because you are doing an integration testing. You need to know how these interfaces are designed. Even you need some use cases. Use cases are normally provided by the user, by the you can say your customer, and based on that, like use cases you can Google as well, but normally these are the raw requirement from the customer, that I say if I press this button then this light should be of some color. So it's a use case. Then for integration testing you also need use case. Architecture at component or system level, you also need to know about the architectural design or high level design of the component or system. Workflows, how this workflow will be done. For example, I will call this component first and I will get this response. So you should also know about how the workflow is over there, how the interfaces are performed, or in which order they will do some actions. And external interface definitions, you also need to know about the external interfaces that we have discussed, you have purchased from third party like this. So test objects, like what to test, what will you test. Test objects mean what to test, what you will test actually during integration testing. You will test the subsystems. Like for example, you have a main system in which you have a hardware system, you have a software system. So you will test subsystems, you will test the databases, you will test the infrastructure completely, you will test, as I've told you, interfaces, even application program interface, even the microservices that you have purchased from third party. So everything on a higher level, not on the component. On the component level we were testing the code itself on the very low level, but now we are on a one step on one higher step, which is integration testing. So during this we will test the infrastructure, databases, APIs, interfaces, etc. What are the typical defects and failures that we can find during integration testing? Incorrect data, missing data, incorrect data encoding. For example, incorrect sequencing or timing interface calls. Like for example, you have said that it will be a 20 millisecond call, and then in response I should get a response in a time span of, let's say, 10 millisecond. So but it was not working properly as we expected, maybe there is some delay. So this you can also identify during integration testing. There could be a mismatch between the interfaces. Then failures in communication between different components, unhandled or improperly handled communication failure between the components. Like if one component is calling the second component, let's say, and there is some error in the call, how the error will be handled? If no, then you have to handle that error as well. So during integration testing you can also find this effect. Incorrect assumptions about the meaning, unit or boundary of data being passed between the components. Maybe you have developed a component and you haven't seen which data normally it accepts, but when during integration testing you provide some data from one component to other, but you do not get the value what you are expecting. So this you can also find during integration testing. Example or typical defects and failures for system testing include, so these were for the component integration testing, and now for the system integration testing, what defects you can see: inconsistent message structure between the system. Maybe two systems are not communicating properly with each other. Incorrect data, missing data, incorrect data encoding, interface mismatch, almost same as component testing. Failures in communication between systems. Maybe the communication protocol is not working properly. You have a hardware system, you have a software system, and you have used some communication serial or parallel communication protocol for the communication. It is not working. So the failure you can also find during integration testing. Then unhandled or improperly handled communication failure between systems. This we have seen already in the component integration testing itself. Then incorrect assumption about the meaning, unit, boundaries of data being passed between the systems. Actually these are the same. Here we have seen on the component level, component integration level, and here we are go through this material. We are reading this material or understanding this based on the system integration testing. Failure to comply with mandatory security regulations. Like there could be some regulations for the systems to fulfill, maybe energy regulations, maybe some other standards. So this you can also find during integration testing. So now we will discuss about the specific approaches and responsibilities during integration testing. So as we have discussed already, for integration testing we have two types of tests. One is component integration testing, the other one is system integration testing. So component integration test and system integration test should concentrate on the integration itself. Like all the components should be tested individually. Then during integration testing we only focus on the integration, as we have discussed that if the interfaces are working properly, if everything is in order which should comply with the standard of integration testing, like APIs, infrastructure, subsystem, etc. So for example, if integration module A with module B, test should focus on the communication between the modules, not the functionality of the individual module, as that should have been covered during component testing. So whenever we are doing integration testing, our focus should be on the communication between the components or modules and not on the functionalities of the component itself, because these components have already been tested during the component testing. If integrating system X with system Y, test should focus on the communication between the systems, not the functionality of the individual systems, as that should have been covered during system testing. So if you are doing integration testing for two components, then only the communication between the components should be tested. Similarly, if you are doing integration testing for the systems, then only the communication between the systems should be tested. The individual systems should have been already been tested during the system testing. So functional, non-functional and structural test types are applicable. This we will see in more detail, that you can do functional testing or non-functional testing on every test levels: component, system, integration or acceptance. So component integration testing is often the responsibility of developers. This we have already seen, that component integration testing is being done normally by the developer in their own development environment, like IDE. So system integration testing is generally the responsibility of tester. Ideally, testers performing integration testing should understand the system architecture and should have influenced integration planning. So system testing normally is bit tricky. Whenever you are doing the system testing, system integration testing better to say, then you should know about the complete system architecture. It really matters, like how the whole system is being developed. Even during component testing, as we have discussed, as we have seen here, this component testing can be done by the developer itself by debugging in his or her own integrated development environment, IDE. But for system integration testing, the very important thing, you should have a final production or target environment as you will have in the real time. Like for example, if you are developing an app for Android, then you should have Android phone itself, and then you should test your complete system on the Android level, on the Android phone itself. So if integration test and the integration strategy are planned before component or systems are built, those component or system can be built in the order required for the most efficient testing. They are saying that if integration test and the integration strategy are planned before the component system are built, then you can develop the component or systems in such a way that it can help your testing. Systematic integration strategies may be based on the system architecture, as we have seen top down and bottom up during last videos. Function, task, transaction processing sequence, or some other aspect of the system or component. Like you should plan your testing in such a way, or you should do your development in such a way that it will help to build a system in step by step, and hence the system can be tested in a very efficient way. In order to simplify defect isolation and detect defects early, integration should normally be incremental, i.e. small number of additional component or system at time, rather than big bang, integrating all component or system in one single step. There is a concept of big bang testing, like you have developed many components together and you are testing all of them together in component integration testing in one go. It's not a good idea. The good idea is CI, continuous integration and continuous testing. Like you develop one component, you test it, you develop second component, you test it, and then test component 1 and component 2 together in component integration testing. It's a good idea, like in an incremental way. Then only you can isolate the faults, you can know the bugs and errors. If you are doing a kind of big bang testing, that you are integrating all the components together and testing them together at once, then maybe you will not able to rectify, you will not able to isolate that in which component you have the fault. So it is the good way to do an incremental testing. A risk analysis of the most complex interfaces can help to focus the integration testing. The greater the scope of integration, the more difficult it becomes to isolate defect to a specific component or system, which may lead to increased risk and additional time for troubleshooting. Like as your system is is increasing continuously, then it is becoming more and more difficult to isolate the fault, and hence the additional time is required for troubleshooting. This is one reason that continuous integration, as I have told you, where software is integrated on a component by component basis, i.e. functional integration, has become common practice. Like continuous integration, we are continuously integrating, we are continuously developing our system, we are continuously integrating the components, continuously testing them, like using automizing and then using automation, and it works in a very good way. Such continuous integration often include automated regression testing, ideally at multiple test level. So this was everything from integration testing, and now we will jump to the system testing.